Your first unit is Introduction to Arduino, on which your first point is Introduction to Microprocessor and Microcontroller. In that point, we have to study what is meant by microprocessor, what is meant by microcontroller, and what is the difference between microprocessor and microcontroller. So first we have to study what is meant by microprocessor. So microprocessor are also known as central processing unit. It is the brain of all computers and many household devices. Multiple microprocessors working together are heart of data centers such as supercomputers, communication products, or other digital devices. Nowadays, microprocessors are used in almost all electronic devices such as printer, washing machine, or mobiles. The first microprocessor was developed in 1971 by Intel Corp. It was a 4-bit. Nowadays, microprocessors are available in 8-bit, 16-bit, 32-bit, or 64-bit. Now these are the organization of microprocessor based system. The microprocessor is made up of three main units: ALU, that is arithmetic and logic unit, then register arrays, and control unit. As shown in above figure, these units are shown along with memory, RAM and ROM, also shown with system bus, which is bidirectional, and input output system is also shown here. Now let we see the function of these element. So first one is arithmetic and logic unit. In this unit, the area of microprocessor computing functions are performed on data. The CPU performs arithmetic operations such as addition, subtraction, and logical operations such as AND, OR, exclusive OR. That results store either in register or memory or sent to output devices. So that is the function of arithmetic and logic unit. Next is register unit. This area of microprocessor consists of various registers. The registers are used to store a temporary uh, during a execution of program. Some of the registers are accessible to user through the instructions. So next one is control unit. The control unit provides a necessary timing and control signal to all operation in microcomputer. It controls flow of data between microprocessor and peripheral devices, including memory. Next is input unit. The input section transfers a data and instruction in binary form, the outside world, to the microprocessor. So that is the input unit. Next is output unit. The output section transfers a data from microprocessor to output devices. So that is the output unit. So next is memory unit. Memory stores a binary information such as instruction data, and that provides information to the microprocessor whenever it is necessary. Next is system bus. The system bus is a communication path between microprocessor and peripheral devices. That means there must be a communication between microprocessor and another peripheral devices. Next is general purpose register. There are 6 general purpose registers in 8085 microprocessor, that is BC, DE, H and L. Each register can hold 8-bit data. These registers can work in pair to hold 16-bit data, and their pairing combination is like BC, DE and HL. So that is general purpose register. Next is program counter. It is also 16-bit register that stores a memory address location of next instruction to be executed. Microprocessor increments the program whenever instruction being executed, so that program counter points to memory address of next instruction that is going to be executed. So that is program counter. Next is stack pointer. It is also 16-bit register. It works like stack, which is always incremented or decremented by 2 during push and pop operation. Next is temporary register. It is a 8-bit register which can hold a temporary data of arithmetic and logical operation. Next is flag register. It is also 8-bit register having 5 flip-flops which can hold either 0 or 1 depending on result stored in accumulator. As shown in above table, the D0 to D7, that is 8-bit with 5 flip-flops are shown here. So S indicates sign, Z indicates 0, AC indicates auxiliary carry, P indicates parity, C indicates carry, Its bit position is as shown in table. Next is instruction register and decoder. It is also 8-bit register. When instruction is fetched from memory, then it is stored in instruction register. Instruction decoder decodes the information present in instruction register. So that is instruction register and decoder. Next is timing and control unit. It provides a timing and control signal to microprocessor to perform operation. And last one is address bus and data bus. The data bus carries a data to be stored. It is bidirectional, where the address bus carries a location to where it should be stored, and it is unidirectional. It is used to transfer a data and address input-output devices. So next one is microcontroller. So microcontroller is self-contained system in which processor supports a memory and input-output contained in a single package. It is designed to execute a specific task to control a single system. It is used to design a multi-purpose computer or devices. Typically, microcontrollers are embedded inside a some device. The microcontrollers are important part of embedded system. So that is a microcontroller. The features of some of the features of microprocessor and microcontrollers are same, like a register, ALU, program counter, flags, stack pointer. Along with this common feature, microcontroller has some additional features such as clock circuit, internal RAM, ROM, serial and parallel IO counters. So these are the another features of microcontroller. Along with microcontrollers had 12 major components. First one is ALU, that is arithmetic and logic unit. Second is PC, that is program counter. Third one is register. Fourth one is timer and counter. Fifth one is internal RAM and ROM. Sixth one is for general purpose parallel input output ports. Seventh one is interrupt control logic with 5 sources of interrupt. Eighth one is serial data communication. Ninth one is PSW, that is program status word. Tenth one is data pointer, that is DPTR. 11th is stack pointer, that is SP. And 12th one is data and address bus. Now, difference between microprocessor and microcontroller. So microcontrollers are used to execute a single task within an application. In case of microprocessor, it is used for big application. The microcontrollers are designing and hardware cost is low. In case of microprocessor, designing and hardware cost is high. Microcontroller is easy to replace, but microprocessor is not easy to replace. In case of microprocessor, CMOS technology, which requires less power to operate. Okay, in case of microcontroller, CMOS technology, which requires less power to operate. In case of microprocessor, its power consumption is high because of it has control the entire system. In case of microcontroller, it consists of CPU, RAM, ROM, input output port. In case of microprocessor, it does not consist of RAM, ROM, IO ports. It is uses a pin to interface peripheral devices. Okay, thank you.